Welcome to Lesson 5 of the course on Introduction to Data Security and Anonymization in Open Data Projects. In the previous lesson, we focused on data security basics for open data teams. This lesson now turns to the methods used to reduce identifiability in the dataset itself. This lesson sits after the security basics, because secure handling always comes first. Before a dataset is transformed, reviewed, or published, the raw and working versions need protection. But once the team is ready to prepare a release version, the key question changes. How can we reduce the risk that people remain identifiable? This lesson is practical. We will look at common techniques that open data teams can understand and discuss. Removing risky values, reducing detail, publishing grouped information, and checking whether the result is still useful. The aim is not to make anonymization automatic. The aim is to support better judgment. A good starting point is to look at the basic methods most teams will encounter. Anonymization is not one single technique. It is a set of methods and decisions that reduce the chance that individuals can be identified. Different datasets need different approaches. The right method depends on the data, the context, the publication purpose, and the remaining risk. The first group of methods is simple in concept, but very important in practice. There are several techniques that can help reduce identifiability. Suppression removes risky information. Masking or redaction hides parts of a value. Aggregation moves from individual records to grouped results. Generalization reduces precision, for example, by using age bands instead of exact ages. Tokenization replaces values with tokens or codes. Although this does not automatically make data anonymous, if the token can be linked back. Data perturbation changes values slightly, often in statistical datasets, to reduce disclosure risk. In practice, these techniques are often combined. Some of these methods remove or hide information, while others reduce precision or modify values. We will look at some of them step by step. Suppression means that something is removed entirely. This can be a direct identifier, a very risky variable, or in some cases, a record that is too unique to release safely. You may remember this example from Lesson 1. Masking means that part of a value is hidden. For example, a postcode may be shortened, or a date may be reduced. These methods can be useful, but they do not automatically make data anonymous. As we saw earlier in the course, removing names or hiding part of a value may still leave combinations that identify people. Often, a safer approach is not to publish individual level records at all. Aggregation and generalization are especially useful in open data because they can preserve public value while reducing identifiability. Aggregation means publishing counts or summarizes instead of individual records. Generalization means keeping that information, but making it less precise. For example, exact ages can become age bands, exact locations can become districts, and exact dates can become months or years. The important point is that less precision can reduce risk, especially in small local datasets. For many open data projects, these basic techniques are enough to start a serious risk discussion. Some situations, however, require more structured privacy concepts. Some anonymization approaches are more advanced. In this course, we introduce them conceptually, not as a technical recipe. K-anonymity, L-diversity, and differential privacy can be powerful ideas but they require careful implementation and interpretation. The practical message is that anonymization is not only about deleting columns. It is about reducing identifiability in a structured and documented way. The easiest advanced concept to understand is K-anonymity. K-anonymity focuses on whether a person still stands out based on quasi-identifiers, such as age group, gender district, or occupation. If a combination appears only once, the person may be singled out. If the same combination appears many times, singling out becomes harder. But K-anonymity is not a complete solution. It depends on which variables are selected, how they are generalized, and what sensitive attributes remain visible. That limitation leads to the next concept. Even if several people look similar, the sensitive information inside that group may still be revealing. L-diversity addresses a weakness of K-anonymity. A group may contain several people, but if all of them share the same sensitive attribute, the group still reveals too much. Differential privacy takes a different approach. It adds carefully controlled noise so that statistical outputs reveal less about any one individual. For most public sector open data teams, the key point is not to implement these methods casually, but to know that more advanced approaches exist and may require specialist support. Whether the method is simple or advanced, the same practical challenge remains. How much detail can be kept without creating too much risk? Anonymization always involves a trade-off. If too little is changed, individuals may remain identifiable. If too much is removed or generalized, the data may become too vague or to be useful. This is why publication purpose matters. A dataset for public transparency may not need the same level of detail as an internal operational file. The goal is not maximum detail. The goal is enough detail for the intended public use, with risk reduced as far as reasonably possible. A practical workflow can help teams make this judgment consistently and more consciously. This workflow brings together the whole course so far. Start with the purpose of publication. Then classify the data and identify direct identifiers, indirect identifiers, also called quasi-identifiers, and sensitive attributes. Assess whether people could still be identified through uniqueness, linkage, or inference. Choose techniques such as suppression, aggregation, or generalization, and then check whether the result is still useful and whether the remaining risk is acceptable. Finally, document the reasoning and obtain approval before release. Sometimes the right outcome is open publication. Sometimes it is aggregation, restricted access, or no publication at all. The next activity applies this workflow to a small fictional dataset. Head over to our practice task and try applying the new knowledge you've gained. This lesson introduced core anonymization methods. Suppression, masking, and aggregation and generalization are practical techniques that can reduce identifiability. More advanced concepts such as K-anonymity, L-diversity, and differential privacy show that anonymization can also be approached more formally. But the central lesson remains the same. Anonymization is context-dependent. Responsible publication requires risk assessment, usefulness testing, documentation, and approval.